In this video, we will finally learn the difference between dependent and independent. No, not clauses, but variables for the ACT science section. My name is Katya Sieberson. I'm the inventor of the Sieberson method, a scientifically proven way to learn anything fast. Let's go talk about some ACT science. There's a common refrain, and I used to be guilty of saying that myself. You don't need to know any science to do well on the ACT science section. Many books say that, many tutors say that, and the more I worked with my students who I helped get to their 33s, 34s, and 35s in the science section, the more I started to understand that it is absolutely imperative to have an understanding of the scientific process and know what are your dependent, independent, and what are your control variables. Think about it. How would you be able to answer a question like this, where it's asking you what is an independent and a dependent variable when you have no idea what the difference is? So before we get into the discussion of the difference between dependent and independent variables, I have compiled a bunch of them. They appear over and over again. They're asking you about your control group, they're asking you about the constants. So before we dive deep into the difference between dependent, independent, control, and constants, we're going to first get a quick understanding of the scientific process. I'll teach you the difference between independent, dependent, control, and constants. But before we do that, I want to preface it with a 6-step scientific process. Why would you want to know the 6-step scientific process? Again, I think it's very important for you guys to know where you are in the scientific process when you're looking at all of these charts and graphs. This is a very grounding and calming experience. So step 1. The scientist makes an observation. Let's say a scientist goes to a party, talks to someone, and he sees that someone's hair has grown tremendously. And the scientist asks, well, what kind of supplements are you taking? And then the respondent will say, well, I'm taking some iron. Maybe that's why. That is step 1. A scientist is making an observation. Step 2 is a scientist going to make or build a hypothesis. And the hypothesis would be something along the lines of, iron supplement is responsible for hair growth or the speed of hair growth. So now you have your dependent variable and your independent variable. Which one's which? We'll find out together. Step 3, then the scientist is going to design an experiment to prove or to investigate his or her own hypothesis. Step 4, conduct the experiment. Step 5. Step 5 is to gather all of the data. This is when your charts and graphs all come in. This is where you are when you're looking at your science passages. The scientist has already gone through step 1, made an observation, built a hypothesis, designed the study, conducted the experiment, and now you're looking at the 5th step. Then you're wondering, what is the 6th step? The 6th step is analyzing the data. It's making an inference based on the data that you're given. Now that you know where you are in the scientific process, let's talk about creating the study, designing the study. You're not often asked to design the study, but you could get a question, something along the lines of, what is the purpose of step 3 in experiment 1? What is the purpose of adding moisture, or what is the purpose of heating up the oven? And understanding the study design is going to be very, very instrumental. Now, let's talk about your independent and dependent variables and controls. I like to use myself as a guinea pig and design a study for you so that you can get a very vivid example. Many of you noticed that I cut my hair, and the reviews are mixed. Some of you are loving it, some of you are hating it. Thank you for all the DMs. I just love how people tell me how to live my life, and I really welcome it. So let's say I listened to some of you and I wanted to grow my hair back, and I would want to do the experiment of 1 and try 3 different supplements. Let's say I wanted to do the iron, magnesium, and then B12. how would I design a study? Well, first, I need my control group because I need some sort of a basis level of my hair growth to compare it to. Because what if my hair already grows very fast and the B12 will only just make me notice how fast my hair is growing. So first, I would take, 4 weeks to just see how fast my hair is growing and then measure how many centimeters my hair grew in the 4 weeks. I would also pay attention to my diet, my exercise, where I am in the world, and whether I'm traveling, because all of those factors have to remain the same for the experiment to work, because your hair growth is dependent on so many other factors. So during the 4 weeks, during the control group, I will also pay attention to all of these other factors, and I would try to do my best to keep those factors the same when I'm introducing my first month of a supplement. My supplement would be an independent variable. My iron will be an independent variable. This will be something that I'm going to be changing. Something that I'm going to be measuring, which is my hair growth, that would be my dependent variable. Then after 4 months, I'm then going to switch to another independent variable, which will be my B12. And then I would be again measuring my dependent variable, which would be my hair growth. And then the third would be magnesium, and then I would measure it again, and that would be my independent variable. So my independent variables are the 3 supplements, and my dependent variable is the hair growth. Now, if I were to make a chart or a graph, my independent variables will always be along the x-axis. My iron, my magnesium, my B12 will always be along the x-axis. My dependent variable, something that I was measuring, my centimeters, will always be along the y-axis. So if you're asked about a study, whether something is dependent, independent, it's easy as pie. Just look at the graph. If you don't have a graph, guess what? You just have to look at a table. On the table, I like to think that the independent variable will always be on the far left and the dependent variable will always be on the far right. But it's not as easy because it's ACT. They would always like to trick you. But I want to share with you something very personal, something that I share with my students, and I literally either give them this flashcard or I take a photo of this flashcard if I'm working with someone remotely. This is the flashcard. By the way, the best book for ACT science. Let me show you. So this is the first one. This is when my students are looking at a table and they're unsure whether it's an independent variable or dependent variable. As a rule of thumb, your independent variable will be on this side and your dependent variable will always be at the end. So that's why I draw a table and I call it ID. So your independent will be here and your dependent will either be the last column or the last 2. So let's practice this skill. Let's take a look at this question, question number 9. If experimental trials were conducted in which combinations 1 through 4 were tested, what would be the independent variable and what would be the dependent variable? Now we're going to go and take a look at this chart. Our locator, our place where the question is asking us to look, is the combination 1 through 4, so just this area. And let's see it. What is changing? Your D, your T stays constant, your V stays constant, and your F is changing. Remember, ID. Your D will be your independent variable, and your F will be your dependent variable. And another really cool trick to determine whether you're looking at an independent variable or a dependent variable is that the independent variable will always be nice and rounded numbers, because the scientists, when they are in step 3, when they're designing the study, they are deciding that they will be varying the M, whatever M is, and then the numbers will always be nice looking and round. When they're taking the measurements are unpredictable. So the numbers with odd or just funny looking decimals will always be your dependent variable. So think back to my example with my hair. I can predict that I will be taking this many milligrams of iron, but I have no idea for how many centimeters my hair will grow. So my dependent variable, what I'm actually measuring, the number will be not so pretty. But the number that I'm deciding I'm going to vary, that number is going to be pretty. Now, the second flashcard doesn't have to do with a table because the data is not always presented to you in a table. The data is sometimes presented for you in the graph, but I forgot. Let's first answer this question. So to answer the question 9, what is an independent and what is a dependent variable? D is going to be your independent, and your F is going to be your dependent. So the answer is D. Now, let's go and take a look at my other flashcard, because I promised you to. This is my second flashcard. This is a graph. On the graph, on the x-axis, you will always have your independent variable. And on the y-axis, you will always have your dependent variable. And right here, it also says independent. This is a legend or an answer key. In a legend, you will sometimes see your independent variables. So, for example, let's actually imagine a hypothetical scenario that we conducted the study, and I want to present to you what a graph of that study looked like. So, you'll have your dependent variable, have your independent variable, and you'll also have a legend. Inside of a legend, you're going to have 4 different components. Why 4? Because we tried 3 different supplements, and we also had a control. So control would be no supplement, and it would be just a straight line. Then you're going to have your iron, and then iron will be a wavy line. Then you're going to have your magnesium, and magnesium would be a dotted line. And then you're going to have your B12, and that would be a line with dots in it. Here, I'm going to have a length in centimeters, so it will be 1, 2, 3, 4, 5, 6, 7, 8. And here, I'm going to have days. 5, 10, 15, 20, 25, and 30. These are going to be days. So after 5 days, my hair grew this much when I was using no supplement. Then it grew slowly. Then I discovered iron. And with iron, it grew much faster. Again, guys, I'm making claims that are absolutely not supported. I'm just giving you an example. Then let's do magnesium. Well, magnesium probably is going to do me some good. So let's pretend that magnesium was even faster. And then after 20 days, and then it just topped out like this. And then B12, let's say B12 at the beginning started just like regular, but then I noticed a significant growth. And then it started to slow down. And then all my hair fell out. But this is an example where your independent variable is going to be presented in your legend, and your dependent variable is right here. This is your length, and these are days. So here we're asked in study 1, which variable was independent and which was dependent. It'll be a lot of fun for you guys. So I'm going to scroll all the way to study 1. I want you to pause this video and answer this question. Remember, we said ID, independent, dependent. So your A was varied and your VH or NV was dependent. It was measured. So let's take a look. Your I and then your VH. The answer is G. So this is another example. This is from a far more recent ACT. This is from Form A10. It's question 30. What was the independent variable in each of the 3 studies, and what was the independent variable across all 3 studies? What? Let's take a look. In study 1, study 2, and study 3, what was the thing that was varied? And if we scan here really quickly, we're going to see that 3 studies done at a lake examined DOC absorption by, drumroll, 3 clay minerals, CM1, CM2, CM3. The CM1, CM2, CM3 was the same as our supplements. This was the same as our iron, our B12, and our magnesium. In one study, we used one thing. In another study, we used another. In the third study, we did something else. So in each study, we could see that what they were varying was maple, oak, pine, magnolia. These are different type of leachate, whatever leachate is. So if we go to the answer choices, we're going to see that in each study was the type of leaf leachate, and across the studies was type of clay minerals. The right answer is G. Remember, independent variable is the one that is being changed. And you can take a look at just take a look at the graphs. Right here in each study, across the x-axis, what is being varied. And then here, you can see that what is being varied from study to study to study is the clay minerals. So this is another very recent example. This is from BO2. Question number 32. Which of the following statements about theta or M summarizes an important difference between 2 experiments? In experiment 1, and then if we do the vertical scan of the answer choices, we can quickly see that it's tied to something being independent variable and something being held constant. So what are we going to do? We're going to go to experiment 1 and we're going to see which variable was independent, which means if we're going to see a graph, we're going to see which one is either here or here. And if we're going to see a table, we're going to be looking for the variable in this side of the table, which was changing. So once we get to experiment 1 and we see a table, check this out. What was independent? Your theta was independent. What was held constant? Your T1, because it stays the same for all of the trials. It's the easiest question in the world, number 32. So the answer is theta was an independent variable, whereas in experiment 2, theta was held constant. Let's check this out. Table 2, experiment 2, in trials 6 to 10, M was varied and theta was 50. If it was 50, that means it was held constant. The right answer is F. Hope this is helping you guys, but I have one more thing with you to discuss. Control and constants. The interesting thing about ACT is that sometimes they're going to want to trick you. They're going to want to trick you all of the time. And if something is not mentioned on the table, if something is not mentioned on the graph, so you're not seeing it as your independent variable and your dependent variable, then you can make an assumption that it was held constant. Let's take a look at this example. So if we look at this question 22, this is from 73G. Which of the following statements regarding W and D best describes a difference between study 2 and study 3? In study 2, and then again, do this technique of a vertical scan where you're going to quickly scan your answer choices, and you're going to see that it's going to be the discussion whether something is held constant or something is varied. So your job is to go back to the passage and look at study 1 and study 3, study 2 and study 3, and then identify which one was varied and which one was held constant. So here we're given 2 graphs. Now quickly tell me, what is your independent variable? Your S is your independent variable. What's your dependent variable? It's called FNAV. FNAV, they're both measured in study 2 and study 3. They're both your dependent variables. Now, you have more independent variables because you have these guys. These are your also independent variables. So for 3 doors, each with D equaling 30. If D was equaling 30, that means D was held constant. And then in study 3 up here, we can see that for 3 doors, each with W equaling to 61 pounds, W was held constant. So in study 2, D was held constant, and then in study 3, W was held constant. So let's take a look at the answer choices. It looks like it's F. W was varied while D was held constant. In study 2, actually is so. D is 30, W is varied. W is 76 pounds, 61 pounds, and 51 pounds. And here your D is varied. So remember, guys, how we talked about how the legend could be your varied variable, how it could show your independent variables? Here is a vivid example. So unless it's mentioned in the graph, you don't even have to read. Unless it's mentioned in the graph either as a dependent variable or as an independent variable, we can just assume it's been held constant. I hope this helps you guys understand the difference between dependent, independent, control group, and the constant. Control group is the one to which the independent variable is never applied. Whenever independent variable is not applied, that is your control group. Remember when I was not taking any supplements and growing my hair? That was me. An experiment of 1, that was my control group. When it's not mentioned in the passage, or it's not mentioned in the graph or chart, you can assume it is being held constant. Something that the scientist varied, something that is changing, and then it is in the table, it's on the side where it says ID, or it is on the x-axis or in a legend, that is your independent variable. And something on the y-axis, or something that it has funny numbers that are very exact, and that is on this side of the table, that is your dependent variable. Let me know if you found this video helpful. Let me know if you want me to make more ACT science videos. And don't forget, every month we choose one lucky person to get on a private tutoring session with me for a whole hour. That's a long time. And if you leave a comment, if you're subscribed to this channel, if you like this video and you leave a comment below this video, you'll be entered into the pool of lucky people who would be considered to get that hour from me. And we choose someone every month. So if you leave a comment this month, you will be entered for this month. If you didn't win this month, don't worry, you can leave a comment again and you will be entered into the next month's pool. All right, guys, I look forward to seeing you in person, and bye.